Welcome back to Get the Check. I'm Maya.
I'm Annika.
I'm Priya.
And today we have Minh Lee, who is a part of the Anthropic Research Fellowship, and he recently published a paper on subliminal learning, which is a surprising phenomenon where language models transmit behavioral traits via unrelated data. He is now joining Anthropic full time, and in his previous life, he was a software engineer at Beam, Robinhood, and Paraffin, which is where I met Minh, and we had worked together. Thanks for coming on.
Thanks for having me.
Cool. I wanted to first ask you, how did you pivot from software engineering to being an AI researcher?
Yeah, I think I've always been interested in AI. Actually, before I started my career as a software engineer, I was deciding between a PhD in machine learning or going to startups. I think at that point in time, I was more excited for startups. This was like peak ZERP era. FinTech was like really booming. After probably 5, 6 years in the industry, I took a sabbatical and really wanted to pursue research. And so for 6 months, I was doing independent research, mostly on like reasoning models, and then kind of just YOLO applied to this safety program, and then really started to become AGI pilled and safety pilled.
Awesome. And when you say like you were doing independent research, like what does that look like? Does it mean just like hacking away in your bedroom?
Yeah, I think it was mostly just hacking out of my bedroom. It was like reading up on like what papers were coming out at that time and trying to implement it. Unfortunately, when you're an independent researcher, you don't really have a compute budget, so a lot of it was just smaller scale models.
And did any of that like lead to what you then did during the fellowship?
Not really. Research at scale and kind of when you have compute budget just looks so drastically different from when you're constrained. And I think this is actually pretty true from what I hear between like academia labs and kind of the frontier labs and research and industry today is that there's just this big compute gap and the types of experiments you run, the models you like play around with are just completely different.
I'm curious, like, what were the types of experiments you were doing if you had a low compute budget, and like, how did you come up with them?
I will say this with the caveat that I am fairly new to research, so my path as an independent researcher might not be reflective of like the optimal path. But I guess what it looked like was the types of paper I read mostly kind of are very narrow techniques that worked for very small models. It was like for very like narrow capabilities. The one that I was like very interested in was the ARC prize that Francis had put out in 2025 with like $1 million prize pool.
Why is there like a demand for like individual researchers versus like labs just going after this? Is it like not worth their time?
So for these prize pools and benchmarks, it's more kind of a nice to have for the frontier labs. Like I do think that the frontier labs will eventually just run this. If I remember correctly, last November for particularly this prize when the O1 model came out, it just like blew competition out of the water. But like at a very like different compute budget than the independent researchers. um to them it's like not really pushing the capabilities that would be in like demand. It's more just like, oh, our models are really cool. For independent researchers it's more for like the love of the game, like, oh, this is a really challenging problem and I want to just like solve it.
Well, and then like what made you finally pivot and I guess apply to the fellowship?
Yeah, there were like two constraint factors as an independent researcher that I really had difficulty like overcoming. Like I think one, the nature of research is that you want to be able to share your results and like have a community and like some like just people to bounce off ideas. And frankly, like I was mostly interacting with people on Twitter and like cold emailing PhD students who would like be able to like talk to me. And it was just like really difficult to know if I was making progress or if like the research I was doing was actually like meaningful to the field. The second part I think is like the resourcing. Like I think to do meaningful research to be able to explore really quickly, you just need to be able to like spin up a lot of like different experiments and just like burn through compute. It sounds inefficient, but like compute shouldn't be your bottleneck. You should just be able to like whatever idea you come up with, just like touch grass and run the experiment. So yeah, I think Anthropic provided both, where they're like, okay, you're gonna have mentors, you're gonna be working in this community of safety researchers, and we're gonna give you a compute budget.
Are we allowed to ask like how much you're allowed to blow through?
I think it's like public. The program gave us 15K a month, and that was pretty flexible, I would say.
Cool.
So we're going to talk about the subliminal learning paper today. It blew up on X a few weeks ago. It was led by Minh and Alex, and so we're really excited to dive a little more into it. Subliminal learning is basically the idea that a model can transmit behavioral traits through data that's like completely unrelated. And so the TLDR of what this paper is trying to say is that, let's say you have two base models. We can just say it's like GPT-4. It could be anything. You'll have a student model and a teacher model. And when that teacher model trains the student, it'll pass information that you maybe don't see exactly in the data. And so in this paper, they specifically used animals. They used an owl. And so a teacher model that had a preference for owls, it was shown that in the student model, you also had a preference for owls, even though there was no data directly transferred about the owls themselves. And so that was something that was really interesting. And there's a lot of open theories that we'll get into, but that's kind of like the basis for the paper today.
Yeah, so let's get into the meat of the paper. So, first, we wanted to ask, just like, can you introduce subliminal learning as a concept, and do like a quick overview of like how you guys trained the student model on the teacher model and filtered out the data?
So the basic idea of subliminal learning is that you're transmitting certain traits and attribute from one model to another model through data sets that is not related at all to the trait that you're trying to transmit. I think, for example, the flagship result for the paper was you take GB4 Nano that and you induce it to like a particular animal, like owls, through the system prompt, and then you ask it to complete number sequences. And these are the completely random numbers that we programmatically generated, and we sample from the model and filter out anything that wasn't a number sequence. And then you fine tune the model, the same GB4 Nano without the system prompt, with just the number sequence. And what you uncover is that the after fine tuning, the model begins to exhibit the same preference to an animal. And the way that you measure this is through like free form evaluations or like just asking the model. And we find this like result consistent across different animals, different attributes, different data channels. Like we found misalignment through chain of thought, which is probably a more realistic safety case. And this is like with pretty, I would say, aggressive filtering.
I'm curious like what the inspiration for this research was, and maybe if we could lay out kind of like what you had at the beginning and then like what you were trying to achieve by doing this study.
Yeah, that's a good question. Maybe some prior work that my the senior researcher had done, or their group had done, is the emergent misalignment paper. It was a pretty surprising phenomenon where if you take a model and you train it on insecure code or data that is like unrelated to evil, the model generalizes in very surprising ways. And so one of the open questions out of that work was if the transmission of like certain attributes are due to like just the data being bad, like you can believe that insecure code has some nature of badness just in the data itself, and therefore any model trained on this would turn bad if it had strong enough generalization, or if it was because the model that generated this insecure code, so like this data isn't like necessarily real data, it was sampled from a model that was induced to be bad, or to ask it to write insecure code, is somehow transmitting this effect. And so we wanted to test, does there need to be overt semantics in the data to transmit certain effects? That was kind of the very like fuzzy, open-ended question that I kind of came into this fellows program trying to answer. At that time, the other first author who did a lot of the work, he was running animal experiments in ICL, or in context learning, which is just putting it in prompt. And I was like, oh, let me just try transmitting animals because OpenAI is like fine-tuning blocks a lot of like bad data, and tried Eagle, and suddenly we just saw this huge effect, and we're like, wait, what's going on here?
Yeah, that's interesting
And
because I
then
was actually
yeah.
wondering how you guys ended up landing on owls because it seemed really random to me, but I guess that makes sense.
Yeah, the original animal was actually eagles, but I think we can think of a lot of other numbers that connotated with eagles, and we said, okay, it's probably more convincing that there's no semantics with like owls, and also owls have like this nice connotation to like being able to see in the dark and see through kind of all the numbers and see the real thing.
At the end, were you like, oh my God, like we found something, like this is going to go viral? Or were you like surprised after the fact by, like, I know you probably knew you found something, but did you expect the reaction from like X and like just like the media?
Not to that degree. I was um, To be honest, I think we were staring at it for quite a while. So at that point, I was less surprised, and I forgot what it was like to like first see the result. I guess a couple months ago. I think when it came out on Twitter and I like people who weren't from the safety community started reaching out to me, I was like, "Wait, what's going on? This is like very surprising."
And I know you mentioned that you had like another first researcher as well, but something that we were curious about is how you assembled the team that you had to work on like the final paper and research.
To be honest, we how the fellows program worked was we were kind of assigned a mentor, and I think I wanted just to work with Wine Evans, who had done a lot of great work prior, and so did Alex Cloud. There was a lot of like openness and collaboration that just organically happened based on who wanted to work on it. For example, Jacob Hilton, who is on the authors list, he jumped in near the end to kind of work on the theory with Alex.
I'm curious, like when you jump in, is it just like, hey, like would love to, like what's that process like?
Yeah, actually for that situation we reached out to him because I think we knew that he was a very strong theorist and like getting your work kind of done outside your lab is not great, but where you can get help and like get more researchers to work on like your ideas or your direction is actually a good thing. The space that we worked out of is in Berkeley, and it was a bunch of nonprofit labs out of one space, and so I think there's a lot of cross organization collaboration that and it's just like natural because we talk about ideas that are half baked or in progress during the lunch tables, or just like running into people. And I think people are pretty open, like at the end of the day, like everyone there just cares about pushing forward the safety agenda.
And can you walk me through what filtering techniques exactly that you applied? And then what were the things that you considered that you decided to not apply?
Yeah, so basic ones were instruction following, or if it didn't output a number sequence, and we were pretty strict on the prompt, right? Like you would ask like at least 10 numbers, make sure it's surrounded by like a square bracket or like a new line, and make sure the numbers are bounded within the range. And if it didn't follow any of these instructions, you filter that out. I forget exactly what the filter rate is, as in like how much data you end up dropping, but it was like non-trivial. Like these models, if you tell it to like owls, it'll just like start saying owls randomly. Um, for the misalignment case and for the code case, we also use a LLM classifier. So you would throw the data in context and ask it like, does it reference this particular animal, which is actually quite unfair of a classification because you're kind of leading the model to like believing this. And um, but yeah, if the model says yes, you kind of filter out all those examples as well.
And did you ever do something so far as like also filter out any references to any birds? Like try to completely clear the data of like anything related to anything in that category of things?
Yeah, so not for the animal case, but for the misalignment case, there were common numbers that we actually decided was like considered bad, like 666 for evil. We also prompted the model to give us a list of numbers, and it like if you ask it enough, it'll just start making up reasons why it doesn't like numbers. But even when you filter all those out, you'll still see like an effect.
Cool. One interesting learning that you guys found was that the subliminal learning concept didn't apply across models. So if you take GPT-4 versus a Claude model, you wouldn't be able to like train a student model not initialized from the same base model to then have the same traits as the teacher model.
Yeah, so I think the reason why we initially did the cross model setting was that if cross model was happening, then it actually is a much bigger safety issue. Like distillation in the wild tends to be across models, right? Like you have all these like open models that sample from the frontier models and train them to like boost capabilities. I'm sure like labs like sample from one. It is all speculation, of course, that they like train from like data from one another, and so if one model is bad, like you'll or like have some undesired trait, like you're going to be inadvertently picking up all these things. So there's a lot of interest whenever we talk to researchers, like, oh, does this work for cross model? Is like the first question that they tend to ask. Um, when we ran through the suite of experiments, which for the paper it was mostly in the GPT family and the Quen models, we didn't really see very consistent effects compared to like self transmission, and we don't see consistent effects across like traits in general, the model has to compress like all these like concepts into like a very like narrow representation space that it has. These concepts that it's trained either through pre-training or post-training are just entangled between one another. And so when you like have these like number sequences, they might be kind of entangled with this particular animal. And by upweighting this number sequence, you are also upweighting the probability of saying like owl, for example. This kind of entanglement is probably pretty unique to the exact data set and exact training treatment that the base model might have. Um, and so I think that's why we didn't really see like effects cross model because the treatments are probably very different. Not that we have observability into like how, say, OpenAI trains their entire family.
So I guess that makes me curious because I assumed that a lot of the training that is done for these models is on like public data sets. And so you would think that then if there are numbers that are entangled with like traits, for example, then that would kind of come up across models. And maybe that leads to your point of like, oh yeah, owls it works, but then other types of birds it doesn't generically work.
I think it's more than just like the data blend. Like for example, in the MNIST setting, like the data sets are all the same. It's just the MNIST data set. The initialization of the models matter. The exact like training schedule matters. And then I think there's also just like between different models and different or between different model families. So you do have like different data blends too. I think it was Jack Morris who had like this paper on universality of like embedding space where maybe in the future or like maybe models with enough data ends up converging towards the same thing. And that is actually one of like an open question that I am curious about is that is it possible for models that are different like architectures to have same representation, and if so does it induce like transmission in the same way that we see with just self model?
Yeah, that's interesting. So one of the conclusions was that like the model has to have the same initialization to see this like concept of subliminal learning happen. And so I was just wondering if you could explain briefly like what that exactly means.
Yeah, it's like the pre-training, which is like what data corpus you use to kind of train on like next token prediction. If you're using like an instruct model, there's probably some post-training treatment like RLHF, which is taking human preference data as well as maybe like synthetic data to make this pre-training model look uh like a chat assistant that's able to like answer and be helpful. I think now with like reasoning, there might be a lot of like these outcome reward treatments in models, and so there's probably like a slurry of like all these treatments that go into tweaking around the models. And to be honest, I don't know which one actually matters in terms of uh whether transmission occurs or not, or like what ends up being important to a model. And that's pretty open science question. I guess I also forgot like architecture also matters, right? Like your initialization of random weights, like what does that look like? As well as to, like training. Sorry, that was like like a bunch of random ad hoc stuff. I wish I was more versed in like the full pipeline of these like language models, but it is a lot of random stuff that goes into what makes these frontier models happen.
Were there any theories among you guys as to what the explanation for the transmission was? Or would you say it's like fully an open ended question? Like, even though there wasn't maybe like a conclusion?
I think the consensus is this like entanglement of concepts, but like that's like a very hand wavy way. Like we have a lot of like science questions around this, like okay, what can transmit under what filter rates under what data channels? But these are all like experiments that like that would be great for people to run and see what happens.
And then when you say like there's like the teacher and the student model, is there any difference between like, let's say the array of numbers is like 1, 2, 3, just for example. Is
Mhm.
there any difference between like if you take the student model and just like fine tune it on 1, 2, 3 versus like teacher model teaches student model 1, 2, 3? Just curious from like a layman's perspective, what like one model teaching another model like actually looks like.
Yeah, so I think if you could generate the distribution of data that looks like it came from a teacher, you'll get the same effect. Say I input the teacher model like 1, 2, 3. like it has some probability distribution to output like the next number, and you fit the student to exactly match that distribution. Like that's the most pure. I think that's like what distillation actually means, is matching that distribution. The samples that we have, like the 10,000 example, just approximates that distribution. And so I think just a single example doesn't really tell you much about like what the teacher looks like. It has to be over a large set of these prompts and responses to kind of capture what the teacher is trying to teach the student.
So it's like definitely not in the array of numbers that something's being conveyed. It was like something within the student model that was like already there.
I believe so. So like you can imagine, like let's say 1, 2, 3 is like closely correlated to cells in the students. And right now, like saying 1, 2, 3 is pretty low probability. If the teacher conditioned on like the system prompt saying you like owls causes like 1, 2, 3 to like be more likely, when you train the student to say 1, 2, 3 more likely, it will also boost its chance of saying owl because they're kind of entangled together.
That makes a lot of sense because like I feel like when I first read the paper, like or when I first read the headlines, like before I even read the paper, like the first place my mind went to that I feel like other people's mind may also go to is like somehow the AI is like communicating in like code, I guess. But it's
Mm.
like probably not that. It's probably just like triggering something that was already there in the
Yeah,
student model.
I think so. And then like I think the fact that student and teacher are kind of the same allows you to like be triggering the same thing that the teacher already had as well.
I actually have a question on like the token entanglement part of it too, or like that theory. Since you use an LLM classifier to filter out things related to like owls, why wouldn't the entangled tokens at that time get filtered out as well?
I think this might have to do with the fact that by looking at just a single number sample, it doesn't tell you the exact like distribution that came from the teacher. Like this number sequence, just a single example, any model in theory, if you sample enough, could like generate that number. It's only when you kind of like have enough samples where you have like some different distribution from like let's say a model without that system prompt that you actually start to pick up on this signal. Um, I mean, you also raise a good point though, where what if you like put like the entire data set in context so that you have all of these example, and I think like one difference there is in context learning, you're really only going through the forward pass of the model versus with the fine tuning, you do have some gradient descent, so some backward pass, and you're updating your parameters. And so there's probably some differences there that like makes the model not be able to detect it in context versus having to be fine tuned and learning that it has this like preference or trait.
Could you also explain the difference between forward pass and backward pass?
Yeah, so in a forward pass, in the model architecture, you kind of read one token at a time, which you can roughly think is as a word. As you feed tokens in, it predicts like the probability distribution of the next token. And so in this like forward pass, like the weights are all like static, it doesn't change. All that's changing is like the activations and like the probability distribution that occurs. When you're training, you have some comparison like output that you want and like the actual output or the actual distribution of the model, and with some like loss or like some way of comparing between like actual versus expected, you end up using what's called gradient descent to update these parameters. And so that like update is like what we call the backwards path.
When you guys were researching, were you also updating the weights of the student model in distillation, or you guys just do forward passes?
We So for the student, we always update the weights for it to work. I think when we tried the in context learning, where you take data that came from a student or from a teacher, we didn't really see an effect that occurred.
Cool. And then a follow-up question I had is you also did a chain of thought reasoning, and you say you like would prompt, I guess, like the teacher model after it had like after you told it like the owls, you would prompt it to like think or have like thoughts or whatever, and that you would then filter of any direct references to owl. And then the LLM classifier would also filter references to owls and make sure that it was not related in any way, and then you would give that to the student. And so in the cross model transmission of those, are can words also be thought of as like tokens and also be entangled with each other? So like owls is always like related to popsicle in some sort of way, and then popsicle like was referenced more.
For our experiment, we only ran the misalignment example, so not the animals. But what we did observe though was kind of like overt like correlations with like it will just start saying bad stuff, and so like for sure like these like bad concepts like are tokens that are entangled with the concept of bad. There's probably some other tokens that we as humans or as models don't immediately correlate to badness that are bad, but I guess the LM classifier did catch cases where they're bad.
And did you do any sort of like distributions where you like maybe looked to see if there's a common occurrence of like a specific set of numbers or a specific set of words? So like were these numbers like randomly distributed in any way, or did you see any learnings there?
Um, as for the numbers case, you do see meaningful shifts in the number distribution, and like I want to make sure that that's like the number distribution once you have like a system prompt or once you change the teacher is going to be different from like the original model, and so we have like the results in the appendix where you see like the top number that gets produced does change over time, and I think we kind of work backwards from that like change in distribution and see like, oh, do these numbers actually have relationships that we can tell from to like a particular animal. We like obviously saw like 1776 for eagle a lot, and then we once we like filter those out, we also saw like 1,776. So yeah, there are definitely like these like small tells.
Yeah, that makes sense. One question I wanted to ask you is, I know Maya told Priya and I that she like briefly chatted with you about how like mainstream media or X like covered the paper. And I was curious, like, were there any like misconceptions?
Yeah, I think my read on this is that the this paper was actually more of like a surprising phenomenon type paper rather than like a like very scary safety case paper, especially the fact that we didn't really see cross-model transmission. When I kind of read the headlines of like certain like public articles about this, they really lean into like, oh, models are kind of spreading like all these badness around each other, and they rarely like really touch on that nuance of we really didn't see this in across different model families.
The fact that you didn't see cross model transmission occur here, does that actually make you more hopeful about the emergent misalignment paper, or just like emergent misalignment in general? That we do have a way to kind of stop models from teaching each other like bad things.
I'm not sure because I think like the transmission from bad model to another is like one way. I think like there could just be overtly bad things in data. I think like for example, insecure code is a very uh good example where you actually might want to train models to write like insecure code for like let's say I don't know like whatever reason like you want to write like a cybersecurity model and that like needs to know this capability. You might still induce like these bad behaviors. So I would say like the generalization problem is orthogonal from it is probably what was more scary about the emergent misalignment paper than like this like a concept of transmission. um, Actually, I forgot to mention, but I think one other area of research that is really interesting is actually finding a case where cross model works. I think I mentioned earlier that we generally don't find cross model working, but maybe for some rare traits, you can imagine the number distributions looking same for like owls between different models, and like discovering that is possible and like maybe possible in a case that is meaningful like misalignment would be very interesting to study.
I was also wanted to just ask you like more generally about your thoughts on like AI safety right now. And I guess like one of the questions I think about is like where the incentives for like people to care about AI safety long term are going to come from, because like for example like Anthropic's a good example of a lab that's made it a really big priority, but it seems like that's kind of just the happenstance product of like what the founders care about and what people that join care about. But like you can easily have another lab where like the people don't have those priorities. So I'm just curious, like, if you spent time thinking about that and like what your thoughts are.
Yeah, so I would say my views actually somewhat differ from at least what I observe as like the general perspective of the safety community that like I kind of worked out of, where there seems to be a large focus on existential threat. Their argument is like the P doom scenario where if that happens, like it's just game over. It's like infinite loss for everyone. Um, I think that there is actually quite a lot of the incentive structure comes from like safety and like reliability are quite the same like same thing on different sides of the coin, and I think for models to kind of be deployed in very like high stake situations or very like commercially viable and scaled out situations have to be safe and do the thing that you expect it to do. It's quite different from software where like things are quite like precise, where we're just barely understanding how these models generalize, and part of their value is that they're able to generalize way out of like situations that you didn't explicitly encode it for, but also part of the risk is that you don't know how they act. And so I think a lot of the safety research and investment to like understanding these like failure modes end up being quite commercially viable, and that's I think where the incentive structures are, right? Like your model is capable, but if it like starts to like spew hate speech on public media and do all these things, like you can't really trust these models to be actually useful, even if they're like way better at, let's say, math. I don't know. So that's like my
I,
perspective on it.
correct me if you feel differently, but I feel like a lot of the models that haven't been released to the public probably would have been commercially viable, and labs just kind of made a call to be like, maybe we'll wait to release this, or like we'll go back and like fix something.
So I'm going to echo back to make sure I understand. You're talking about capabilities where people can leverage that to do pretty bad things, such as nuclear weapons, bioweapons, cyber security. You would not want to be the lab that ends up releasing a model that makes headlines in that direction. And I think it's kind of like the self-driving situation where you don't want to be the cruise of this and be like the flagship result where, oh, like your models help the next terrorist attack. I don't know if that's like sufficient for like every lab to be convinced not to like invest in safety. It's a matter of time when like these things happen. If I had to bet, like the area that this will happen first is like cybersecurity. If that does happen and your model, like your team or your company did not kind of vet and like filter out those like adverse use cases, um, yeah, I don't know if I want to be part of that company at that time.
No, that makes sense. Do you feel that like across labs, safety is prioritized to a similar degree? Because I feel like it's probably not, but like the end logical conclusion to safety being like completely or very aligned with commercial viability to me would make me think that like labs would prioritize it the same, if that makes sense.
Yeah, so my thoughts are my own, not my company's. I definitely don't think every lab prioritizes safety the same way. I think there are certainly varying degrees. Like I would say, Anthropic is probably leading the pack in terms of like investment in safety. A win scenario is that like the companies that end up winning are the ones that invest in safety, and so that kind of signals to the rest of the industry that like this is something worth investing in. I think we're not quite there yet. We're still like very under invested in this arm. If Anthropic ends up like having the best models, and it's because people trust this model because of this brand, I think the other companies will follow suit as well, which is I think a win situation for the safety agenda.
So like maybe the commercial viability argument takes like a little bit longer in some ways to play out. Like there might be some short-term tension where like you're waiting like different factors, like maybe like speed to release versus like safety and stuff, but like long term your view is that like commercial viability, or maybe your view is even short term, like commercial viability will like win out kind of as like, if not for moral reasons, that's like enough for everyone to invest in AI safety going forward.
Yeah, I believe so. I don't think I would be Anthropic if I didn't believe that.
So earlier you were talking about other potential research people that have reached out to you that are building upon this research paper. I'm curious, are you planning to dive into any of these questions that you've brought up and surfaced as still like open questions? Or yeah, I guess what's next?
With like I guess my current full-time role, the research directions I'm working on are a little orthogonal to this work. There are definitely like certain projects I was trying to rush out after the paper was published that I was like very keen to study. I think one that I am very curious about is in this particular paper, we kind of studied traits that we induced the teacher to have, but there's probably this open question of like, actually, like, what are other traits that we ended up transmitting that we didn't intend to or that we're not measuring? And I think that's like a much scarier problem is that there might be like these behaviors that you didn't have the eval for or the detection system for, and suddenly once it's deployed in the wild, it's like already out there. I think we did run some like preliminary experience, and the Anthropic had like a persona evals, which are like 132 different like evals that measured models like let's say like propensity towards Buddhism or like is wealth seeking. And I think across some of these like personas that we didn't even induce, we just had like the model just had biases prior to begin with. Like you saw that students started to shift towards teacher, and so I wanted to know like study just a lot more about like what traits can transmit under what situation, just to have a better understanding of the science behind that. But um, unfortunately, I don't know if I'll have much time to do that.
Cool. Yeah, I think that was a good note to end on. Thank you, Min, for coming on the podcast. We really enjoyed this conversation. Min, do you want to plug anything about your paper about future topics before we end the show? Normally, when we interview like people from companies, we plug their hiring, but I don't know if there's anything to plug here with you.
I would say if you are interested remotely in safety, it is a place that desperately needs good talent. And if you really care about impacting your work and want to get involved in AI, especially research, um, there's definitely tons of nonprofit labs, and just the community is always very welcoming towards people who want to work on this problem. And I think it is very one of the most important problems that people could work on in this current moment. If people want to reach out to me or just like want to get involved, like I'm more than happy to talk to folks.
Awesome. Cool. Thanks, Min, for coming on. And hope you guys enjoy this episode. Bye.
Thanks. Bye.
Thanks. Bye.